We are currently facing a moment that can be described as follows. China is not betting on a single project, but on an entire ecosystem, on industrial scale, on speed, and on scaling up. And that makes things interesting because what's happening there right now has less to do with a momentary victory and more with building supply chains and starting cycles. Just to give an overview, in addition to the government programs, a whole wave of semi-private rocket companies is growing in China, and they all have one thing in common. Many are taking a cue from what SpaceX has done and are adapting exactly the components that make sense technologically and economically. That means methane and liquid oxygen engines are becoming popular, larger payload classes are being tackled, and reusability is on the roadmaps. Sometimes a bit greener than SpaceX, sometimes surprisingly directly copied, sometimes as a hybrid of Falcon 9 and Starship design. My name is Serwan and this is Mars Chronicles. Here are a few names you should remember. Landspace is one of the more visible companies. Equally important are Galactic Energy, iSpace Space, Pioneer, Deep Blue Aerospace, and Link Space. Some are purely private, while others work extremely closely with provincial governments and state partners. This creates a very Chinese market-driven speed combined with political support. What stands out at the moment? Three things. First, iteration instead of perfection. The startups launch early, often, and publicly. Mistakes are part of the development, not the end of it. That's a culture that has so far been associated more with the United States and China. It's now emerging as well, though under different political conditions. That creates speed. Secondly, standardization and scaling. It's no longer just about a cool prototype. Many teams are building production lines, modular upper stages, and standardized tanks. That's important if you really want to bring down the cost per launch. Third, technology mix. Some companies are focusing heavily on methane and liquid oxygen engines. Others are improving classic rocket propellant, one designs. When it comes to reusability, there's everything from vertically landing first stages to reusable upper stage experiments. And yes, some designs look like they've gone through a SpaceX filter. But many teams combine this inspiration with local engineering expertise and their own manufacturing skills. Politics and money play a key role. Beijing funding programs, provincial subsidies, and military supply chains keep many projects alive even when commercial orders are not yet coming in large numbers. At the same time, this means that technical milestones are celebrated politically, which creates pressure but also provides resources. What are the risks? Well, the usual launch and test failures, like when Space Pioneer conducted a static fire test of their first stage for the Tianlong 3 rocket, and the rocket unintentionally lifted off. In times like these, supply chain shortages must also be taken seriously, and finding the balance between quality and speed is of utmost importance. Additionally, there are also regulatory uncertainties. China's spaceflight ecosystem is in flux, and regulations for private launches are still a patchwork. Companies can survive on a provincial subsidy or be slowed down by a change in regulations. A quick word on bigger topics. China has ambitious infrastructure plans, from greater orbital activity to the joint international Lunar Research Station initiative with Russia. The question is not just who flies most often, but who builds the logistics, the depots, the ground and launch infrastructure, and makes permanent presence possible. And that's exactly where many Chinese players are quietly investing. Why should we pay attention to that? Because an alternative model is taking shape here. Not an exact copy, but a unique mix of state planning, private entrepreneurship, and extremely high speed. If that works, it will change the geopolitical equation. Frequent launches, low costs, and local manufacturing mean that space travel is no longer the domain of just a few nations. If you take a closer look at China's private launcher scene, you quickly realize that it's not a homogeneous group. There are winners, there are shaky candidates, and there are companies that are just now learning how brutal spaceflight really is in practice. Let's start with the most well-known name. Landspace is something like the Chinese counterpart to SpaceX's early development goals. Their focus is clearly on Methalox, which is exactly the propellant path that SpaceX has taken with Raptor and Starship. The rocket Souk 2 is the real test here. After a failure on the maiden flight, Landspace made improvements and eventually achieved a successful orbital flight. The crucial thing is not the success itself, but the learning curve. Landspace has demonstrated that. They can absorb mistakes, adapt hardware, and fly again. That is the most important quality in this business. In December 2025, they launched their new Suke 3. The launch was successful, but the propulsive landing did not go as planned. The entry burn of the booster worked, but something went wrong during the startup of the landing ignition. That caused the upper stage to burst into flames and crash completely uncontrolled just next to the designated landing zone. The precision here is quite remarkable. Then there's galactic energy. Galactic energy seems more conservative at first glance. The Series 1 uses classic propellants, is small, reliable, and flies relatively well. This isn't a Starship moment, but rather the Chinese counterpart to Rocket Lab's early Electron years. Less vision, more cash flow, and that's exactly what makes the company dangerously competitive. They fly often, they deliver payloads, and they're building trust with customers. At the same time, they're working on larger launch vehicles, but without spreading themselves too thin. A-Space is the opposite example. Big ambitions, aggressive timelines, but several setbacks. Failed launches with the Hyperbola series were especially painful. AI Space wanted to move quickly toward reusability, but spaceflight doesn't forgive shortcuts. The company still exists and continues to operate. But it's a good example that you don't automatically get SpaceX speed just by copying SpaceX. Space Pioneer is very exciting. This is where it gets interesting because Space Pioneer is very openly experimenting with Falcon 9-like architectures, large first stages, clustered engines, clear reuse goals. The Tianlong rocket is ambitious, maybe even too ambitious for its current level of maturity, as we saw in this failure. But these are exactly the companies you need to watch, not because they're guaranteed to succeed, but because if they do, they could scale up very quickly. Then there's Deep Blue Aerospace. Deep Blue is strongly focused on vertical landing techniques. The company is testing reusable suborbital vehicles and is gaining experience exactly where China has long been weaker. Precise control during re-entry and landing. That is very reminiscent of SpaceX's Grasshopper phase. No orbital flight yet, but valuable groundwork. What you see with all these companies, failed launches are no longer a career ender. In China, they are increasingly being accepted as part of the process. That's new. 10 years ago, a spectacular failed launch would hardly have been politically acceptable. Today, it's analyzed, put into context, and work continues. It's at this point that you notice something important. In the end, it's not the rendering that decides, but the hardware. We constantly talk about methane engines, landing maneuvers, reusability, but that often remains very abstract. That's why I built something that makes this whole discussion tangible. Because we're talking about the future of rocket engines here, we're making it something special. I'm giving away this Raptor 3 model to you. Just write in the comments why you want to win this engine. The most creative or exciting answer will get it sent to them. Of course, I'll link the Prusa printer and the model for you below in the description. But let's get back to China's space program. Now, let's quickly talk about the numbers, because they're crucial. China has massively increased its launch frequency in recent years. In 2023 and 2024, there were well over 60 orbital launches each year. As of now, 2025 is again in this range, with a growing share of commercial missions. The trend is clear. China is not only launching a lot, but is increasingly using new launch systems. That's technologically risky, but strategically sensible. At the same time, China is operating its own space station, Tiangong. It's smaller than the International Space Station, but it's fully functional and permanently manned. What's important here is less about the size and more about the independence. Tiangong is a test bed for long-term operations, resupply missions, and crew rotations. Exactly the know-how that will be needed later for the Moon or cislunar infrastructure. And that brings us to the big framework, ILRS. The International Lunar Research Station, which China is planning together with Russia, is not an Apollo copy. It is designed for the long term, modular, built step by step, and prepared robotically. Much of it is still in the concept and rendering phase. But the political intention is clear. China doesn't just want to land once, China wants to stay. They are also one of the most important driving forces behind Artemis. When you put all that together, a clear picture emerges. The Chinese space strategy is not based on a single major prestige project, but on breadth. Many companies, many approaches, many launches, some will fail, but those that remain will form an ecosystem that can be scaled up quickly. If you compare China's space strategy with the American one, a fundamental difference becomes apparent. The United States is currently relying heavily on a few extremely dominant players, above all SpaceX Falcon 9, Falcon Heavy, and Starship. That's not an ecosystem, that's a monolith with enormous power. If it works, the lead is gigantic. If it fails, there's little redundancy. Zhongguo is deliberately taking the opposite path. Not one company, rocket, or architectural leap, but many parallel paths: land space, galactic energy, space pioneer, deep blue, and iSpace. They compete with each other, copy from each other, and learn collectively at the same time. That's inefficient in detail, but extremely robust at the system level. The price for this is obvious. China currently doesn't have a rocket that can match the operational maturity of a Falcon 9. Reusability so far exists almost exclusively on the test stand or in suborbital demonstrations. There is no Chinese rocket that launches, lands, and launches again week after week. And above all, there is no Chinese company that operates spaceflight like an industrial mass production, at least not operationally. While SpaceX is betting everything on a single massive technological leap, Starship China is focusing on evolution, bigger rockets, gradual reuse, higher launch frequency, and more operational experience. The goal is not the spectacular solution, but control over launch capacity, logistics, and cadence. That brings us to the structural weaknesses of this approach. First, quality assurance. Many companies mean many supply chains. That increases the likelihood of serial defects. Second, transparency. False starts are more accepted than before, but causes, design changes, and real lessons learned are often hard to understand from the outside. Third, international trust. Western customers are still hesitant when it comes to Chinese launches. Export controls, international traffic in arms regulations, and political risks. China compensates for exactly that with something the West increasingly underestimates: the gigantic domestic market, Chinese satellites, Chinese constellations, and Chinese military and civilian payloads. Even if not a single Western customer flies, these companies have enough work to survive, learn, and grow. Their space station Tiangong is not spectacular, but it exists, it works, and it forces China to carry out regular launches, manned missions, emergency procedures, and supply logistics. It is precisely this routine that will later determine the success or failure of lunar architectures. In the context of International Lunar Research Station, this becomes especially relevant. The planned International Lunar Research Station is not a quick victory, but a long-term development. Robotic at first, modular with a focus on energy supply, communication, and logistics, not a flag-planting moment, but presence. That's exactly what China's approach is designed for. So the big question isn't, does China have a Starship today? The question is, does China even need one? Because if China has several medium-sized, partially reusable rockets in 5 to 10 years that can launch reliably, frequently, and cheaply, then you can build infrastructure without a giant leap all at once. Slower maybe, but more stable. That's the real bet. The United States is betting on disruption. China is betting on endurance. Both can work, both can fail, but they are completely different philosophies. And that's exactly why you shouldn't laugh at Chinese startups. Many will disappear, some will merge, but the few that remain won't be the Chinese copy of SpaceX. They will be something of their own, shaped by political backing, high launch frequency, and a market that doesn't ask for public relations but for reliability. When you put all that together, the Chinese startups, the government support, the International Lunar Research Station space station, and the increasing launch frequency, it becomes pretty clear. China is not currently trying to overtake the West. They want to show that they are a world power, independent of Western launch services, independent of geopolitical supply chains, and regardless of whether SpaceX works or not. That is especially interesting in terms of defense and sovereignty, and that's where the real danger for the West lies. Not in a single rocket, not in a spectacular test, but in the sheer number of iterations. Many launches, many failures, and many small improvements. No hero, no miracle solution, no Elon moment, but industrial spaceflight in rapid succession. The United States is betting everything on speed and disruption. That can work. Starship can change everything or fail. China, on the other hand, accepts that the path is longer but controllable. The goal is not to make the fastest leap. The goal is to still be there in the end, when others have overreached themselves. And Europe is caught in between and hesitates, too governmental for real iterations, too political for real willingness to take risks, too fragmented for industrial clout. While China experiments and the United States escalates, Europe debates responsibilities. The uncomfortable truth is, space travel is back in geopolitics, not as a symbol, but as infrastructure. Whoever can launch determines the pace, tempo, and dependencies. Those who can't become customers or spectators. So China's bet is not a bet on the best rocket, but a bet on endurance, learning curves, and a market big enough to forgive mistakes. And that's exactly why these companies should be taken seriously as a system. If you like these assessments, subscribe and let me know in the comments whether you think China's approach is smart or too slow for this new space era. My name is Sirwan, and this was Mars Chronicles. Thanks for tuning in. Per aspera ad astra.